welcome to the concepts video on angles. So first, let's take a look back at a circle. Okay, so let's say we have a circle here, and here's the center, and we want to describe a particular point on the circle. Okay, so what we can say about it so far is that, well, this xy point here is a distance r, is a fixed distance r from the center, right? But the thing is, if we pick a point over here and try to say the same thing, we can actually say that same exact thing and say, well, this point is r distance from the center, so is this point, and so are all the other points on the circle. So that characteristic of being r, or a radius, or a fixed distance from the center, that doesn't really cut it, right? Because it's too vague, because all of the points on the circle are an r distance away from that center, right? So we'll need another tool in order to describe where we are on our circle other than the radius. And this is what compels us to define and look at what are called angles. Okay, so what is an angle? Let me just write a quick definition here. So it's just a measurement between two lines or rays, okay? And it's basically looks like this. Okay, so we have the initial side, which that's what it's called, and the terminal side, okay? And then here's the angle part, okay? It's usually denoted with a Greek letter called theta, okay? So here I'll just label. So this is the initial side, if I can spell here, initial side. So initial just meaning this is where your angle starts, and traditionally it's drawn pointing horizontally to the right. So kind of like that, like you see here. I can even draw an arrow there. Okay, and then on the other hand, this one here is called the terminal side. Terminal side, because this is where your angle finishes. And you can also draw an arrow here if you'd like. Okay, so normally we represent the counterclockwise direction. So like, let's say here's a clock, right? Here's 12 o'clock, 1 o'clock, blah, blah, blah. So the counterclockwise direction, we represent that as being the positive angular direction, okay? So in this case, we would have some positive angle, whereas if you go in the clockwise direction, this is like the negative direction for angles, okay? That's usually what's chosen as our convention there, okay? So an important note to make is that an angle is a measure of not linear. It's not a linear measure, meaning like it doesn't measure the length of something or the distance of something, but it's a measure of rotation, like how much something is rotating or turning around a fixed point. Okay, so let's see. Keeping that in mind, we're going to introduce. So we're all familiar, or we should be perhaps familiar with degrees. And not Fahrenheit, not degrees Fahrenheit or degrees Celsius, not that kind, but the degrees as in like 360 degrees is equivalent to one full circle, okay? So let me just write that. So one full circle, or one full time around a circle, one full trip, going all the way around, that would be that's equivalent to saying 360 degrees. Such as half a circle, going halfway around a circle, is just half of that, so 180 degrees. And furthermore, a quarter of a circle, if you divide that one more time by 2, that gives you 90 degrees, right? Okay, so now let's see an example. Alrighty, so here we're going to give the degree measure of the angle shown on the circle, on these circles here. Okay, so for this first one, we'll call it circle A, and this one is circle B. Okay, so on circle A, we have this arrow denoting an angle. Okay, so we said 360 degrees is one trip all the way around, right? So this is 360 degrees to go one full revolution. And to go a quarter of that, we would just have to divide our number by 4. Okay, so 360 divided by 4 gives us a 90 degrees. So that's the measurement of the angle that our arrow is denoting. Okay, and now if we look at circle B, we actually kind of have two different angles to identify here. This first one, the solid line, which I'm going to put a little arrow at the end of, this one looks like about a third of a quarter. And you can kind of think of it as a pizza if you'd like. So this, we know a quarter from part A. We know that a full quarter is 90 degrees. So then if you take a third of that, all we have to do is divide that 90 by 30, so 90 degrees, divide it by 3, and then you get a 30 degrees. So this one right here, this little angle there, that's 30 degrees. How about if we were to figure out this one here, the one that I'm drawing a little arc on? So if we figure out the angle of the dotted line, which I now should shade it in, if we find it to here, that gives us 2/3 of our 90 degrees, of our quarter slice, right? So if we take 90 and divide it by, well, actually maybe multiplication works better. So what is 2/3 of 90? You just have to multiply like this. So then we reduce that, and that becomes a 30 degrees. But now we have this 2 here, so that dotted line angle, that's going to give us 60 degrees. Okay? So that's 60 degrees there. So sometimes we see funny pictures like this, and it's like, what is that trying to tell us? So what's really going on here is if we look at the big angle, so the one that starts here, and we go all the way around, we trace that, and we end up at this arrow, right? So that means we went a full circle, because we touched back to the horizontal axis, and a little bit more, okay? So that means we have 360 plus whatever is left over. Okay, so here I'm doing kind of like angle A, and this angle, that tiny one, is angle B, okay? So angle A is denoted by 360 plus whatever's left over, and that looks like about 1/3 of a quarter, which we found out on the previous slide. So 1/3 of a quarter is kind of like saying, so we have originally our 360, that's just there from rotating that full circle already, okay? And then we have plus 1/3 of a quarter of our full circle, which is 360. So if we calculate this, we get 360 degrees plus 360 divided by 12, okay? And that's just 30 degrees here, which is equal to 360 plus 30, okay? So if we calculate that, we just get 390 degrees. So what that means, okay, so let's just keep that in mind. And now let's look at angle B, okay, the little tiny one. So angle B starts here on the horizontal axis and just moves up right there to the angle, okay, to that line there. Alrighty, so that's just, again, 1/3 of our quarter. So 1/3 of like 90 degrees, let's say. So that is a 30 degrees. And we've solved for that on a previous slide. So the thing with these is that if we look at our picture, we see that both of the arrows end up pointing at the same line, right? Or at the same place, okay? And they started at the same place, but the thing is, with angle A, we traveled kind of a longer distance rotationally, okay? We traveled through more angles to get to where we're at now, to get to where we end up, whereas B started at the horizontal axis and just went up like that, okay? It didn't go all the way around. It just went once up to our angle there, okay? So these angles, 30 and 390, they would be called coterminal. Coterminal. And the reasoning behind that is because these are angles that finish or that end up in the same position. Okay? Position. Alrighty, so the important thing here is coterminal. So what's emphasized is the ending on where the angles end up pointing. Okay? So it doesn't really matter like where they begin. We could have started, I don't know, we could have gone 2 times around. Let's say we started here, okay? And then we go 1 time around. So that's 360. And then we go another time around. So that's 360 plus 360 is 720 plus that little bit. And we end up in the same place. So that would give us, so we went 2 times around a full circle. So that's 2 times our normal 360 plus whatever was left over. And we already determined that leftover piece is just a 30 degrees. So we have 720 plus 30. And that gives us 750. Alrighty, so that 750, that's also an angle that is coterminal with 390, and it's coterminal with 30 degrees as well, because all 3 of these angles end up in the same place, right? All the arrows end up pointing in the same line there, okay? And something that we notice about each of these is that, you know how we just went around one more time to get each, like, bigger angle, right? We added 360 here, we added 360 to get here. So that's really important to keep in mind, is that whenever you want to find a coterminal angle, when you're given like an angle measure, let's say like 40 degrees or something, and they tell you, okay, find an angle that is coterminal with this one, all you have to do is add or subtract 360 degrees from where you're at, okay? Until you get to a range that you want to be in. So let's do an example of that.